Hello, everyone. My name is Jacob Alagasao, and today our group is going to report about the Chapter 2, Designing the Highway. And this report is presented by our group, Blacklist, and the members are Jacob Alagasao, Louis John Equipado, Baldwin Kifo Serafin, Carlito Mahina Jr., and John Gabriel Gilon. Consistency. Consistency is the most important single rule in the highway design. That is, by making every element of the roadway conforms to the expectation of every driver. Among the promising approaches to improve highway safety performance is the concept of highway design consistency. Drivers expect the highway agency to provide them with clear information and guidance through a variety of road signs and avoiding abrupt changes in the traffic as well as the road standards. If these guides and directions could be planned properly to convey one single message at a time, and if these directions could be followed smoothly and easily without undue haste or changes in speed, then the road facilities are considered satisfactory, meaning if we're able to follow directions smoothly, then there will be no problems. Experienced highway engineers recommend that highway signs and directions should be integrated as early as preliminary layout studies. Now, AASHTO is the American Association of State Highway and Transportation Officials. In 1914, the American Association of the State Highway Officials, or AASHO, as was established as an association of state, territorial, and district of Columbia Highway Department and the Federal Highway Administration. The name was expanded in 1973 when the Department of Transportation was integrated into the association, renaming AASHO to AASHTO, giving the officials of this agency the power to govern its operation. Engineering activities were implemented by standing committees with the task of preparing specifications, manual, and standards representing the current highway engineering practice. AASHTO publications include transportation materials, specifications and test, specifications of highway bridges, geometric design standards, and numerous policy statements and guides. AASHTO publications are authoritative, meaning it is reliable as the information are accurate or true. References are made in these books and periodic manuals. The association also publishes the AASHTO quarterly reports on current highway and transportation subject, including trends in forecasts and legislations. Roads and highway. Roads and highway is defined as strips of land that had been cleared and further improved for the movement of the people and goods. Road has a somewhat broader application in usage while generally used to describe public thoroughfare. A road is a wide way leading from one place to another, especially if the specially prepared surface which vehicles can use, and it can also refer to railways. Highway. The term was first used in England to describe a public road built by digging ditches on both sides and heaping up the earth in the middle, creating a way higher than the adjacent land. Basically, it's a major road, usually in rural areas or big roads. Highway now connotes a higher state of development than road, but the words are almost interchangeable. Expressway is a divided arterial highway for through traffic and with full and partial control of access and generally provided with grade separation at major intersection. It is a wide road for fast-moving traffic. Freeway is an expressway with full control of access. Control of access is a condition where the rights of the owners or occupants of adjoining land or other person's access to light, air, or view in connection with the highway is fully or partially controlled by public authority. There are two types of control of access, the full and the partial control of access. Both of them has the authority to control access and are exercised to give preference to through traffic by providing access connection to selected public roads, but the difference between them is the crossing at grade or direct private driveway connection is not permitted, while in partial control of access, the crossing at grade and private driveway connection are allowed. Through street or through highway. Every highway or portion thereof on which the vehicular traffic is given preferential right of way and at the entrance to which vehicular traffic from intersecting highways is required by law to yield right of way to vehicles on such through highway in obedience to either stop or sign or yield signs erected thereon. It is a street where vehicles passing through have the right of way as opposed to vehicles from intersecting roads which are obligated to stop before entering. Kaya na may uban nakabutang na not true street which is gitawag na tong dead end and or one street na no cross streets. Parkway. Parkway is an arterial highway for non-commercial traffic with full or partial control of access, usually located within a park ribbon or parklight development. Arterial street is an arterial route that carries traffic to the nearest access point or through tap traffic. Arterials provide access to the adjacent property, but often with restrictions on entry and exit points. It is a wide road, usually divided with an area of grass and trees on both sides and in the middle. Highway and parkway might be sound the same sometimes, but the difference between a highway and a parkway is that highway mainly has two or more two lanes having no tolls through in it, and parkway on the other hand is a decorated road and has traffic signals too. There are basic considerations in planning arterial roadways. First is selection of the routes. Of course, it is important to know the best place to build arterial. Two is studies of the traffic volume, like learning about how much traffic it can divert from one place. Three is origin and destination, the location of the arterial roadway and how far it will go. Four is accident experience. Width should not be less than 15 meters, must carry at least one lane or traffic in each direction, should be at least 1 kilometer in length, should skirt neighborhood areas rather than penetrate them. On grade design system street, arterials are spaced at about 600 and 900 meters apart. And when accident hazard is not a factor, the minimum volume to justify arterial road is 300 vehicles per average hour during the day and 450 vehicles hourly during peak periods. Sometimes peak hour traffic volume on designated arterial road exceeds the capacity of two-way streets. Now, to increase the arterial capacity, the following solutions are enforced. During peak hours, parking is prohibited on one or both sides of streets. Parking is prohibited several meters away from each side of the road intersections or corners, and right turn is allowed on red signals anytime with care. Left turns are eliminated on congested intersections, and the direction of the traffic is reversed in the center lane to provide more lanes in the direction of heavier traffic flow. Collector Street. It is a street form, smaller mesh grid pattern where passengers are picked up from service streets and carried to the arterials. Large commercial enterprises or amusement facilities like drive-in theaters are mostly fronting arterial roads. More like sumpay ni siya sa arterial roadway, like a street padong sa arterial roads. So Local roads is defined as a street or road primarily for access for residents, business, or other adjoining properties. It is also defined as a road constructed and maintained by the local government. Refer to local roads or street na accepting traffic from collector streets and distribute the traffic through subdivisions, neighborhoods, and business areas to individual homes, apartments, business sites, and industrial sites. Highway capacity. Highway capacity is defined as the minimum number of vehicles that are reasonably expected to pass a given point over a given period of time, usually expressed as vehicles per hour. And under ideal conditions, one freeway lane can be accommodated about 2,000 passengers cars per hour, and a two-lane road can carry up to 1,000 passenger cars per hour in each direction. There's an obvious relationship between vehicle speed and highway capacity. As the volume of the traffic approaches capacity, the average speed is markedly reduced. Average annual daily traffic, or AADT. AADT or ADT refers to the traffic volume or flow on a highway as measured by the number of vehicles passing as partial station during a given interval of time. It is called average annual daily traffic if the period is less than 1 year. Volume may be stated on hourly observed traffic volume or estimated 30th hour volume commonly used for design purposes. Some highways agency use traffic volume for 5 minutes interval to distinguish short peak movements of vehicles. This is determined by counting the total numbers of vehicles to cross a point of both direction on a highway during a year and dividing this value by the number of days in that year. So example, okay, ADT is equals to total volume of vehicles traffic for 1 year. I-divide na to siya of 1 year, so 365 days. So design speed. There's no single set of geometric standards that will apply to all highways. For every highway segment, decisions regarding appropriate control for each of the many details or requirements must be addressed individually or separately. AASHTO define design speed as the speed determined for design and correlation of physical feature of a highway that influence vehicles operation. It is the maximum speed that can be maintained over a specific section of a highway when weather and traffic conditions are so favored the design feature of the highway governed. AASHTO recommended that the design speed be set to the greatest degree possible to satisfy the needs of nearly all drivers both today and throughout the road anticipated life. For economic reasons, the geometric feature of a certain road section are designed for speed from 30 to 50 kilometers per hour, and yet some motorists drive faster on a straight road alignment or less sharply curved sections. Under these situations, highway design adaptive control by reducing the super elevation combined with easement curves, delineators, stripping signs, and rumble strips to alert motorists and inform them that they are approaching sharp or blind curves. Selection of the proper road design speed is one of the most important decisions to make because it sets the limit to curvature, sight distance, and other geometric features. But because of the limited funds, there's a strong temptation to reduce this design speed. Such kind of decision is unwise because the alignment grade and sight distance after the roadway has been constructed and paved along the landscape and right-of-way become more difficult and expensive to adjust or to correct. The AASHTO practice is to classify first the highway as rural or urban, then as freeways, arterials, collectors, and local. Rural collectors and local facilities are classified as flat, rolling, or mountainous. Although the design speed percentage used is 80 km per hour, highway designers project the design speed up to 120 kilometers per hour to guarantee against the future obsolescence as well as the increased margin of operating safety. The high-speed road design must anticipate future generation of high-speed vehicles and advanced transportation systems that may operate on many of these road alignments. Although the design speed of more highways is governed by construction cost, the concept of the relatively high-speed design for freeways is regardless of cost. They are planned for a nationwide high-volume traffic and high-speed network. So in this table, you can see the freeway in urban and rural areas has a preferred design speed. Also in arterial, collectors, and local, they also have a designated speed in both urban and rural. So in table 2, it shows that the AASHTO minimum design speed of rural collectors and local roads based on current ADT. The cross-section of a typical highway has a latitude of variables to consider, such as the volume of traffic, character of the traffic, speed of the traffic, and characteristics of motor vehicles and the drivers. Highway designs usually adopted cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities. For a low-volume traffic facilities, modifications of the features like the soldiers' width in rough areas are usually employed to reduce costs. A cross-section design generally offers the expected level of service for safety and recent study. Highway design usually adopt a cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities, but for a low-volume traffic facilities, modifications of the features like shoulders width in rough areas are usually employed to reduce cost. A cross-section design generally offers the expected level of service for safety, and recent study shows that a 7.20 meters wide pavement has 18% less accidents compared with a pavement narrowed than 5.50 meter wide. A 720 meters wide pavement has 4% fewer accidents than the 6 meters wide roadway. And accident record shows no difference between the 6.60 meters and 7.20 meters wide pavement. For the 6 meters and 7.20 meters wide pavement with 2.70 to 3 meter wide shoulder, recorded accident decreased by 30% compared to a 0 to 0.60 meter wide shoulders and 20% compared with a 0.90 to 1.20 meters wide shoulder. It appears that the above difference in accident potentials may not justify higher standards, particularly when traffic volume is low. The driver's instinct when overtaking or allowing other cars to overtake or meeting oncoming vehicles is to look at the surface width of the highway and see the kind of surface where to position his car. Originally, the total surface width of the roadway was only 4.50 meters, but due to the increase of number of vehicles using the roadway, the width was adjusted to 4.80 to 5.40 meters. Lately, the width of the road was standardized to 3 meters for first-class paved one-lane highway, and now 3.60 meters wide surface was adopted standard for freeways and other major traffic roadways, although there are strong demands to increase it further from 3.60 to 4.20 meters. For two-lane rural highways, a 7.20-meter wide surface is required for safe clearance between commercial vehicles and is recommended for main highways. And for collector roadway, a 6-meter wide surface is acceptable only for low volume traffic, including few trucks are traveling thereon. And for local rural roadway, the minimum surface width is 4.80 meters for a 30 kilometers per hour design speed. And for urban roadway, the minimum design width is 3.60 meters, although 3 meters is allowed where space is limited. So this is the cross-section of a typical two-lane highways and a multi-lane highways and freeways, or as half section. So this is the divided highways where it is a less than 100 kilometers and a 2.50 stop lanes, or less than 60 kilometers, 2.50 stop lanes. And this is the undivided highways where speed is less than 100 kilometers per hour for 3.50 lanes and 250, and a 3.50 lanes and a 2-meter stop lanes. Road shoulder. Road shoulder or verge is defined as the portion of the roadway between the edge of a traffic lane and the edge of a ditch, gutter, curb, or a side slope. So this is muna siya ang shoulder road na to. Nani where side dra mo park ang mga truck na nga. So the importance of the road shoulder is road shoulder serves as a place for vehicles to stop when disabled or for some other purposes. Road shoulder considerably reduces road accidents. The road capacity is decreased and accident opportunities increase if a shoulder road na to is too narrow or omitted in design. Shoulder should be continuous along with the full length of the roadway. It also adds structural strength to the road pavement. Shoulder increases the horizontal side distance on curbs. It reduces accident potential when vehicles stop during emergencies. Most of the road shoulder in rural areas are unpaved or having a width of 60 to 120 centimeters wide, either earth-filled or gravel surface that during rainy days, the drivers are hesitant to occupy. A continuous narrow white line strip at the edge of the roadway that separates the shoulder serves as the guide to drivers during the bad weather and poor visibility conditions. The white strips tend the drivers to stay in the traffic lane and the vehicles seldom infringe on the shoulder. So the policies on geometric design recommended that outside shoulder should be paved for at least 3 or 3.60 meter wide if truck volume is more than 250 in the design hour. The recommended width of left or median shoulder is 1.20 to 2.40 meters with at least 1 meter paved. If there are 6 or more lanes, the median shoulder should be 3 meter wide or 3.60 meter if truck volume in the design hour is exceeding 250. For arterials with ADT less than 400, the usual shoulder width is fixed at 1.20 meters minimum, although 2.40 wide is much preferred. When the design hour volume ADT exceeds 400, the usual minimum shoulder width is 2.40 meters, although 3.60 meters is recommended. For urban arterial road, similar shoulder without curve is suggested unless for urban arterial road, similar shoulder without curve is suggested unless needed for proposed drainage. The width The median shoulder on 4 lanes divided arterials is fixed at 90 centimeters as minimum. For 6 or more lanes, 2.40 to 3 meters shoulder width is recommended. And for rural collector roadway, 60 meters wide graded shoulder is required for ADTs less than 400. And for ADTs over 2000, 2.40-meter wide shoulder is recommended. And as the tables show, this is the width of the roadway for undivided highways. So these are the design for a shoulder road, which is the street alignment, shoulder details with stop lane. And these are the design for street alignment, shoulder detail with stop lane, guardrail. Guardrail kay katuman ng kuan, a rail that prevents people from falling off or being hit, more like a coral. More siya coral sa kalsada. So this is the straight alignment shoulder detail with stop lane used as cycle path or footpath. So ang design ani kay wag na siya bike lane or dira pwede manlakaw. So diri kay no stop lane, no footpath or no guardrail shoulder. So sa figure, this figure should, so in this figure, the shoulder detail is footpath only. So the last is the alignment and curved shoulder details. Nay, duha ka buhok inside shoulder and outside shoulder. So outside shoulder can I paved and napoy stabilized. Next is the cross slope, which will be discussed by our next reporter.
Good day everyone, I am Luijan Equipado and today I'm going to discuss about my assigned topic. So the first topic is the cross slope. So what is the cross slope? The cross slope is provided in all tangent section of the roadway. Slope usually falls in both direction of the center line of the 2-lane highway, except where the super elevation of the curves direct all the water towards the inside. Here I have a picture of the cross slope example. It's basically two slopes that cross each other at the center line of the roadway. For a high type pavement, the crown or slope is often 1% to 2% range. However, steeper slope are strongly recommended. So here we have an example of the 1% to 2% slope, and as you can see here, the example of the crown road is just like the road that we can see outside that has a 2% range of slope. So what is the purpose of the cross slope or much steeper slope? The purpose of the cross slope is to reduce water on the road so that the driver can have a safe and comfortable experience on driving. The cross slope also have a shoulder. It can be paved shoulder or gravel shoulder. The filled shoulder cross slope range from 2% to 6%, although 4% is the most common. As for the gravel shoulder, 4% to 6% slope is satisfactory, and 7 is the effective drainage for turf surface. So here I have an example of the paved shoulder and the gravel shoulder. The paved shoulder is made of cement, while the gravel shoulder is made of gravel or smaller rocks. There are also many types of road slope. The first is the cross slope, the most standard one. And the second is the parabolic slope. It's only applicable if the gutter is deep enough to support in draining water on the road, while if the gutter is not deep enough, it's advisable to use the combination of uniform slope with the parabolic curve. That's the third type of slope. And now we're going to move on for the next topic, the cut or fill slope. For the what is the cut or fill slope? From the word itself, it means cut, magbawas, and fill, magdagdag. So here I have an example of cut or fill slope. As you can see on the picture, the mountain has been cut through and has been built with the road. As you can see here in the left side of the picture, you can see the cut slope or the back slope, and beside the road or at the bottom of the road, you can see that the fill slope or embankment. Kani siya nga mountain is gibawasan sa gilid mo nang siya cut slope nya gidagdagan siya para mag-support siya gi-flat in gifillan og soil then gi-flat para makabuild og roads. So here, earth fill of normal height is safe on a slope of 1 and 2 ratio. Second is slope of cuts through an ordinary undistributed earth fill remain in place with the ratio of 1 and 1 slope. Cuts could be as step as 1 and 2 ratio, and sometimes 1 and 4 ratio proven to be stable. Here I have a picture of the 1 and 2 ratios example of earth fill of normal height. And now the second picture is an example of the cut through ordinary and distributed earth of 1 and 1 ratio. Now we're going to talk about the advantage of the flat side or back slope. The first advantage is the back with a back slope of 3 and 1 ratio or even flatter, cars could be directed to back into the road and will come to stop or continue down the slope with no risk of overturning. Second, flat fill slope are visible from the vehicle at full extent, giving the roadway a safer appearance. Third, with a visible slope for a being low and flat, vehicles could be positioned or parked closer to the edge, and on 2-lane roadway, facilities parking would be farther from the opposing traffic. There are also recommended policy on geometric design. We have 3. First one is the 6 and 1 slope ratio be adopted on embankment than 1.2 meters high and 4.1 on a higher fill. Second is the 1 and 2 slope ratio is allowed to height greater than 6 meter. Number 3, the cut slope should not be steeper than a 2 and 1 ratio except only solid rock or special kind of soil. Here is an example of the rock cut ratio from 1 and 2 or 1 and 4. It's only applicable on a special kind of soil or rock types. The AASHTO also has a policy stipulated that where cut or fill slope intersect the original ground surface, cross-section must be rounded to blend the slope with the natural ground surface. When the side slope requires embankment with a suitable retaining wall, any of the following materials could be used depending on the natural condition. Here I have a first illustration or picture of what the ASHTO. As you can see here, I have two example pictures of cut or fill slope. The first one is the left picture. As you can see, the original ground surface has been cut and filled to build a safe and flat roadway. While the second one here, as you can see, it also has been cut and filled but has a retaining wall to support the new flat surface for building a road. The materials that could be used depending upon the natural condition for the retaining wall is: first, hand-placed stone; second, cement rubble masonry; third, concrete blocks; four, conventional reinforced concrete; 5, T or counter-furted design; 6, cribs assembled from timber; 7, precast concrete; 8, metal elements; 9, tied back peeling; and 10, lastly, is the earth is reinforced with metal or plastic hand. So here, I have an example of cut and fill slope in real life situation. As you can see in the first picture on the left, the mountain has been cut through and flattened and filled with soil so that they can start building a safe and flat road. And the second picture is an example of rock cuts or cut rocks that has a ratio of 1 to 1 and 2 or 1 and 4 slope. The number of lanes. The number of lanes in segment of highway is determined from the estimated volume for the design year AADT and highway lane capacity as expected level of service. As to policy, accept a dually divided 16 lanes roadway with 4 lanes in each direction for an inner freeway and 4 more lanes in each direction of the outside. Next is highway median. So what is highway median? From the word itself, it means road and something in the middle of the road. It could be barrier or flat surface with plants or signs. Yeah. For example is the road near the Park Mall. As you can see, the road there has many types of medians, and its purpose is to prevent accidents. Advantage of highway median. There are 13 advantage according to the book. The first is it is effective means of reducing highlight glares, conflict, and accident between opposing streams of traffic. Second, the median often refuse between opposing traffic stream of cross traffic, and pedestrians could traverse each stream at separate maneuver. Third, median provides available space for left turn lane. Fourth, it makes the turning of vehicles smooth and safe operation. Fifth, where space and cost permit, a wide median is highly recommended. For rural section of freeway, the 18 to 27 meters wide median is being adopted. Number 6. The policy of geometric distance states that 3 to 9 meters of median with appropriate for suburban or mountain situation. Number 7 is for rural or urban arterials, 18 meters median or wider is preferable because it allows the use of independent profile and at the same time minimize the crossover accident. Number 8, median with 6 to 18 meters wide allow drivers to cross each roadway separately. A 4.2 to 6.6 meter median width provide protection for turning vehicles. Number 9, curved median with 1.2 to 1.8 meter width serves serves as partition separation of opposite traffic control device. Number 10, the width of traversable median should be wide enough to prevent vehicles running out of control from reaching the opposite traffic. Number 11, the 15 to 24 distance between landed edge is favored, but a specific value is not stipulated. Number 12, cross slope of the median should not be greater than 6.1, but preferable is 10.1. Lastly, dense planting of rows hedge serve as safely crash barriers. For narrow median, you need to provide the tearing device, non-transversable energy absorbing device, non-transversable rigid barriers, and GM barriers. The tearing device is a 2 sets of double strip printed on the existing pavement, raised diagonal bars, low curving, and swallow dishes. Non-traversable energy absorbing device. The line chain linked fence is 1 meter high and supported by steel posts and argument by cables at the bottom of the midpoint. Non-traversable rigid barriers are metal guardrails. And lastly, GM barriers is high non-mountain slope face concrete barriers called New Jersey. It is cast or extruded in a place or precast in a section and set in the position by the crane. And here I provide an example of highway median. It is median under structure. As you can see in the picture, it is the barrier or a wall between two roads. It also set as a protection from crashing and accident. Here is also an example of a straight alignment median in current section. As you can see here, it's covered turf covered median, and the other one is the turf or stabilization median, and last is stabilization or turf median. It also has you call this a barrier or rails. And the third example is a centroid median with a floor plate and a covered if no parapet or has a parapet median. And lastly is also a central void with barriers. Here is an median approach and also has an arrow that shows where direction to drive. And here I have an example of the deceleration lane and insertion lane. As you can see in the picture, you can see the arrow is the arrow here is saying that it is the traffic flow, and you don't have to slow down here. Well, here as you can see, there is an arrow that form a parabolic curve towards the check posted safe speed for RAM, or it is called the slowdown after turning into the deceleration lane. And here are the design or the example of barrier curves. As you can see, it has different kind and shape, and also has a curve and gutter here. You can see this kind of barriers and curve in the side of the road. So let's proceed to grade line. So what is grade line? Grade line is defined as the longitudinal profile of the highway as a measure of how the center line of the highway rises and falls. As you can see here on the picture, you can see an original ground surface and a grade line. The grade line is where the engineer will be building a flat road over these mountains. So the grade line provide a line of design on where build a road. It also show us which part of the mountain will be cut off and will need to be filled up with soil. So in laying the grade line, the designer must consider the following. The first is where earthworks is minimal and consistently meeting slightly distance in relation to grade line. The economy is one of the main consideration. Second, in mountainous areas, the grade line must be considered to be balanced excavation against embankments to get minimum overall cost. Third is, in flat area, the grade line is set almost parallel to the ground surface but sufficiently above the ground or drainage purposes. Number 4. Undesirable native soil should be provided with sufficient covering. Number 5. Grade line elevation along the river or stream is governed by the expected level of water flood. So that's all for my topic. I hope you learned something. So let's proceed now to the next reporter, Baldwin Serafin. Thank you.
Vertical curve over crest. Crest vertical curves are curves that connect inclined sections of roadway, forming a crest, and they are relatively easy to design. The principal control in the design of crest vertical curves is to ensure that minimum stopping sight distance, or SSD, is available throughout the vertical curve. All vertical curves should not be shorter than the established minimum over crest. This is governed by the sight distance requirements, but sometimes a case of riding may demand longer curves than the sight distance. Some designers prefer no vertical curve to be shorter than 300 meters. The minimum curve length was suggested by AASHTO, or American Association of State Highway and Transportation Officials, to be 8 times the velocity in kilometers per hour for a distance of meters. The vertical distance from the intersection of the straight grade line to the curve is equal to 1/8 of the product of the algebraic difference in grades and the length of the curve in stations. This is called the maximum correction. The rate at which the curve departs vertically from both tangent grade line is proportional to the square of the horizontal distance from the end of the curve. The correction at any intermediate point is obtained by, number 1, multiplying the maximum correction by the square of the horizontal distance between the near end of the curve and the point. 2. Divide this product by the square of 1/2 the length of the curve. The sight distance and the length of the curve can be related to each other in one of two ways. The first possibility is that the sight distance is less than the length of the curve. Alternatively, the length of the curve could be less than the sight distance. This is the illustration. Right of way. Railway right of way means a strip of land that is granted through an easement or other mechanism for transportation purposes. A right of way is reserved for the purposes of maintenance or expansion of existing services with the right of way. It is a right to make a way over a piece of land, usually to and from other piece of land. A successful freeway and expressway operations closes the roadway from direct access to adjoining property and some local roads or streets. If local traffic and land used are to be opened, it must be served by service roads originally planned as part of the main freeway. Frontage road shall be permitted to enter connecting cross streets only at a distance of at least 100 meters for rural road and 50 meters for urban conditions. So this table is the minimum right-of-way widths for rural and urban freeways at grade in meter. Stopping sight distance. Stopping sight distance is one of the several types of sight distance used in road design. It is a near worst case distance a vehicle driver needs to be able to see in order to have room to stop before colliding with something in the roadway, such as pedestrian in a crosswalk, a stopped vehicle, or road debris. Insufficient sight distance can adversely affect the safety or operations of a roadway or intersection. It is defined as the longest distance that a driver could see the top of an object 15 centimeters above the road surface where the design height of the driver's eye above the pavement is 105 centimeters. Stopping distance is made up of two elements. Number 1. The distance traveled after the obstruction or object is seen and before the driver applies the brakes. 2. The second distance is consumed while the driver applies brakes for the vehicle to stop. The distance covered could be expressed by the following formula. D equals T M over S. Braking distance, D is equal to meter per second square over 2 GMF, and D is equal to meter per second squared over 19.6 F, where M over S is equal to initial speed in meter per second. T is detection, recognition, decision, and response initiation. GM is acceleration of gravity, 9.80 meter per second squared. F, coefficient of friction between the tire and pavement. The highway level being flat is assumed by the preceding formula. The braking distance is decreased when traveled uphill, while it is increased when traveling downhill. The following formula can be used to express the braking distance on slopes. Braking distance is equal to D is equal to braking distance, or M, is equal to D is equal to meter per second square over 19.8 times F plus G, where G is the longitudinal slope of the roadway or percent grade or 100. Uphill grade is positive while downhill grade is negative. So this table shows the minimum stopping sight distance wet road. The passing sight distance. Passing sight distance is needed where passing is permitted on two-way highways to ensure that passing drivers who use the lane normally reserved for opposing traffic have a sufficiently clear view ahead to minimize the possibility of collision with an opposing vehicle. The distance includes the distance traveled during the perception or reaction time and the distance traveled while accelerating to the passing speed. It is the longest distance that a driver can see the top of an oncoming vehicle while the driver's eye level is 1.05 meters above the pavement surface. The relationship between the passing sight distance, the algebraic difference in grades, and the length of vertical curve is represented by the following equations. L is equal to 2S minus 943 over A, where S is greater than L, and L is equal to AS2 over 943, where S is less than L and L is length in meters. L is equal to length required of vertical curve and S is specified sight distance. A is algebraic difference in grades expressed in percent. The design of two-lane highway of passing over crest is generally practical only on flat grades because the longer vertical curves are required to provide passing sight than stopping sight distance. F is equal to meter per second square minus SE over 9.8 rm, where meter per second is equal to meter per second, and rm is equal to radius in meter, SE is equal to super elevation. At 75 km per hour, the maximum coefficient of side friction on dry pavement, as determined by curve testing, is approximately 0.35 for smooth tires and 0.4 and 0.5 value with normal pavement. The two table shows the AAS-HTO minimum passing sight distance for design of two-lane highways and AAS-HTO recommended maximum coefficient of side friction. Road alignment. The alignment is the route of the road, defined as a series of horizontal tangents and curves. The profile is the vertical aspects of the road, including crest and sag curves, and the straight grade lines connecting them. It should be consistent. An abrupt change from flat to sharp curve and long tangents followed by sharp curve should be avoided because it will create hazard and invite accident. There are two types of road alignment. One is the horizontal alignment and two is the vertical alignment. Horizontal alignment, it includes straight stretches, curves, etc. While vertical alignment, it includes upward or downward gradients. And lastly, this is an example of both alignments.
Good day everyone, I'm Carlito P. Mena Jr. and I'll be the one who next to report. So, circular curves. Circular curves is a segment of circle, an arc. The sharpness of the curve is determined by the radius of the circle and can be described in terms of degree of curvature. So, a vehicle traveling in a curved road is subject to centrifugal force. This force is balanced by equal and opposite forces developed through the super elevation and side frictions. Sharpness of a curve is dependent on its radius, and degrees of curve are inversely proportional with the radius. So, muna ang formula sa degree of curve ug sa radius. Sa kaning radius kay masyang if exact kuan siya arc definitions and approximate siya sa curve definition. So, the degree of curve is expressed either by the arc definitions or the curve definitions. So, kaning table degree of curves, so muna siya ang sample pakita. Arc definitions. The degree of curve is the central subtended by a 30 meters r of the curve. And curve definitions, the degree of curve is central angle subtended by 50 meters curve. So, natay line formula sa radius, which is sa kaning formula kay ato ning gamiton if exact curve definition siya. So, then mani ang table sa sharpest permissible horizontal curves for given design speed and super elevation. The maximum allowed super elevation rate before was 0.12 but now it's 0.10, except on low volume gravel roads. The policy on geometric design recommended that first, for design speed of 50 km per hour, the normal cross slope is 1 degree to 21 or even flatter curves. Second, for a 120 km per hour design speed road, the normal cross slope is 0 degrees to 15 or flatter curves without super elevation. In each of these solution, the total side friction is less than 0.04 for an adverse cross slope of 0.02. Super elevation runoff. The super elevation runoff is the length of the roadway required to change the outside lane cross slope from a flat cross slope to a fully super elevated section. Then, money ang picture sa super elevation. High velocity, centrifugal force, centripetal force, side or lateral friction. Then, the center of each individual roadway at a profile grade is maintained while raising the outer edge and lowering the inner edge to maintain the desired super elevation. It is done by raising up the outside edge of the pavement with relation to the center line until the outer half of the cross-section is flat. So, mani ang figure sa super elevation of curves. So, mao na yung table guys sa suggested minimum length of super elevation runoff for 2-lane 3.60 meters lane. So, makita na to sa picture. Then, H2 American Association of Highway and Transportation Officials recommended the runoff length to vary both with super elevation rate and the design speed, but with minimum state of appearance and comfort to riders. A roadway that lies in a cut where the grade line is nearly flat may create sag by lowering its inner edge. This may not drain surface water. It is recommended that 60% to 80% of the runoff from an elevated alignment should be on a tangent. It's possible to achieve super elevation by raising the outer edge of the alignment twice the usual distance. So for wider roadway, the length given on table 2.9 should be increased as follows. First, if 4 lanes, individual value increased by 50%. Next, 6 lanes, individual value increased by 100%. Widening of curves. A provision for a wider roadway is necessary on sharp curve for 2 lanes pavement under the following reasons. First, to force the drivers to shy away from the pavement edge. Second, to increase the effective transverse vehicle width for non-tracking of front and rear wheels. Third, to give additional width due to the slanted position of front wheel to the roadway's center line. The last one is for a 7.20 meters wide roadway, an additional width of 30 centimeters is necessary on an open curve highway. Reverse circular curves are seldom used on modern highways, but reverse curves that are provided with proper length easements between them are acceptable. If no easement curve is allotted, curves on opposite direction should be separated by tangent several meters long. Roads with compound curves that change abruptly from one sharpness to another confuse the drivers and in turn they shift position within the lane and sometimes veer out of it. Compound circular curve of different radii is considered as poor design, especially in rural areas. H2 recommends again that the radius of the flatter curve for rural highways should never be more than 50% greater than the of the sharper one. For urban intersection, this is easement curve is considered, which introduces the changes in radius gradually. Super elevation changes along this transition section. Islands. An island is defined between traffic lanes for control of vehicle movement and for pedestrian refuge. It may range from an area delineated by barrier curve to a pavement area marked by paint. On that grade intersection in which traffic is directed into definite paths by island is termed as channelized intersections. Island is included in the design of intersections for the following purposes. First, separation of vehicular flows. Second, separation of conflicts. Third, reduction in excessive pavements areas. Fourth, reduction of traffic and indication of proper use of intersections. Fifth, arrangement to favor a prominent turning movement. And the last one is location of traffic control devices. These are usually the main cause of confusion and accidents which led to road accidents. When cross traffic meets at flat angle, head-on collision could be more serious. A right angle at 75 degrees to 105 degrees is most favorable, giving the driver that opportunity to assess or calculate the position and speed of oncoming vehicles. By channelization, funneling is also effective in preventing overtaking and passing in conflict areas. A well-studied super elevation is an important adjunct to channelization that regulates the vehicle speed and first, prohibited turns are prevented. Next, refuge may be provided for turning or crossing vehicles and pedestrian. Figure 226 general types of shapes in island. We have the angle between intersecting streams of traffic can be smooth and favorable. Prohibited turns may be prevented. Speed of vehicles controlled over approaching intersections. Funneling vehicles into narrowing opening prevent overtaking and passing conflict area. And refuge provided for turning vehicles. Then the last, drivers commanded to merge into moving traffic streams. The third one, by channelization, refuge may be provided for turning crossing vehicles and pedestrians. The fourth one, the drivers has to face only one decision at a time. Hence, conflicts can be avoided. The last one, it provides location for the traffic control devices like signs, signals, and refuge for pedestrians. Types of interchange. The types of interchange form of freeway interchange requires selection, the confirmation that is best suited to a particular situation and demand. The functions of freeway interchanges are: first, to provide separation between two or more traffic arteries. Second, to facilitate the easy transfer of vehicles from one entry to the other or between local roadway and the freeway. Diamond type interchange recommended where the freeway crosses non-freeway arterial, and the clover leaf type interchange recommended for freeway and arterial intersections. Intersecting arteries are separated and free of intersections. The diamond interchange is the most cost-effective form of interchange. Objections to the cloverleaf interchange design. First objection, it requires large area of land. Second, at higher design speed, more time is consumed just to traverse the longer loops. Third, vehicles making left turn execute 270 degrees right turn and travel greater distance, becoming unpleasant and hazardous due to the sharp curves and step grades. Last one, vehicles leaving the curved loop in one quadrant whereas those entering the adjacent loop from the true roadway. Under this type, waving and merging movements are separated. Alternative cloverleaf design with collector distributor is recommended for one or two through streets if added light paving and structures can be justified. When freeway meets freeway, where traffic movement is heavy, interchange provided with directional left turn in all four quadrants. Figure 227, types of freeway interchange. We have Y-type interchanges and T or trumpet. Then figure 228, types of freeway interchanges. We have diamond interchanges, partial cloverleaf. Figure 229, channelized interchanges. We have directional interchanges and through freeway with rotary flyover with roundabout. Then the last, figure 230, fully directional interchanges. We have 4 level, A, B 3 level, C 3 level also. Figure A roadway at 4 levels is appropriate where land is very expensive. B and C is more open design, common in 3 level of roadways, require mid control or grades and side distance.
Good afternoon, everyone. So today I will continue our topic and I will talk about highway and intersection upgrade. So highway and this intersection upgrade. So it is stated that all highways except freeway have intersections at grade. The intersection area is considered to be part of connecting road. So dapat yun di magawa magkita-kita og highway nga way intersection, di ba? So part naman gina sa highway ang mga intersections. So in this area, all crossing and turning movements occur. For right angle intersections with little traffic, the street sign is more than sufficient. So para yung aning example, right angle na siya kanang murag simple lang gyud nga intersections ba usara ka linya ang mosulod. So dari dili na ta kinahanglan og mag-channelize diri. So ang paigo na kaayo ang magbutang lang ta og street sign, okay na kaayo. So for number 2, for Y intersection or other related conformation where vehicles meet at unfavorable angles, it may require channelization. So og diri kanang basta magsugod na gid ka complicated ang karsada kanang daghan na kay silang mga daghan na kay mag-abot nga bisa gikan from different nga giagian magabot sila at certain point so mulibog na gid asa driver maglibog na gid kag asa man day kaani dapat muliko. So kinahanglan ta mag-channelize dire. For example, aning mga Y intersection, kinahanglan ta mag-channelize dire kay para tuloy-tuloy ang daloy sa katong karsada. Same dari mo pa ni ang mga Y na kinahanglan nato i-channelize. Ani. So number 3, the flare design will involve the following. Letter A, widening the entering traffic to allow deceleration of the car and clear of through traffic. B, widening the living lanes to provide acceleration and merging from traffic lanes strips. So kaning parallel type di ay kay kabantay mo before siya mosulod sa iyang linya kay na siya murag gamay iyaha nga kasudlan kay para continuous ang iyahang dagan. So before gid siya mo merge sa main nga traffic, diara siya mo agi kaning gamay nga karsada in order to merge continuously. The number 4 is intersections must accommodate large truck and the radius of all curves must be sufficient enough to accommodate them. So, dili kay makaingon tag must accommodate large truck kay syempre dili ra gyud mga auto ug mga motor ang pwede moagi diha, pwede gyud moagi ang mga dagkong sakyanan like mga prime movers o mga cargo truck. So, it must accommodate these large trucks. So a careful traffic count and projected future improvements precede the design of critical sections based on the data gathered on traffic count. A lane capacity could be determined, including the number of lanes to be constructed. So the lane capacity could be determined, including the number of lanes to be constructed. So my next subtopic is freeway entrance and exit. So a single lane on ramp vehicles flows into the outer continuing freeway lane. The design is either a tapered blending to the lane or an auxiliary lane parallel through the lane. In either case sufficient, the lane is required to allow the vehicles to accelerate and merge into ongoing vehicle streams at speed near to the freeway. So for example, kaning parallel gid siya kanang naa siya specific nga length o kaning 30 meters before siya mo merge sa into traffic diagonal. However, kaning sa tapered kay mura siya nahimong curve gani nga mulhaw siya gamay o gamay na lang ang iyang kwaon para sa iyang igsulod niya sa iyang merge niya sa traffic. So 30 meters dari sa parallel o sa tapered kay na 180 meters o niya corresponding nga length niya of ramps in meter nga naa diri sa kilid. Same pod sa exit. Nag-entrance ta, same pod sa exit, vehicles leaving the freeway need a distance to accelerate and clear of the flow ongoing traffic in a situation where one lane could not meet the traffic demand. So two lane exist is necessary. In that situation, an auxiliary lane must be added to the freeway at least 800 meters before the point of exit. Even with one lane exit, an auxiliary lane is necessary for it reduces confusion and congestions. So, ani kay, for example, mo biya na ka sa freeway, so dapat layo pa lang gidaan. Mo anhin na ka sa imong lane nga para mo lane na kadaan kung asa ang para exit sa freeway. Mura ra gud nag sa kanang mo sa SRP magani makabantay gyud ani sa SRP kanang na ma-channelized man na SRP na dito nakaputang sa ubos sa karsada nga na to Cebu City nya na to SRP ay dili day na nakabutang dito to Cebu City nya na to sa usa nga lane nakabutang pod to tawag galing to U-turn slot niya sa usapod nga lane ay to si LX Bridge. So ana na siya kay para dili ma-confuse ang mga motorista. So railroad and highway separation. So the main question asked in a railroad and highway separation is where one is to go over the railroad or the highway. So unsa man gyud na sa babaw ang railroad ba or ang highway ba? So what are your ideas? So let's get into it. If the highway is to go over the railroad, the structure itself is lighter and the highway load is much smaller than the railroad loads. With regard to the vertical clearance height, the railroad requires a minimum of 7 meters as against 4.8 meters clear distance above the highway. So, og ang agyanan ko no sa trend naa sa ilawom sa highway, syempre okay ra kay siya kay ang highway mas gaan siya. It is the structure itself is lighter and the highway load is much smaller than the railroad. Kumpara nato sa train. Yeah, with regards to the vertical clearance ko no, kay if ang train na sa ilalom, dapat mag-need siya at least 7 meters ang iyang vertical clearance gikan sa highway o sa railroad nga karsada. However, if ang highway na ilawom niya ang railroad na babaw, special provision is required for removal of rainwater that falls within the opposing area. If the groundwater is high in the vicinity of the crossing, the roadway must be sealed against leakage and be made heavy enough to prevent it from floating. So, yung aning situation, like nasa babaw ang iyang railroad, special provision kuno is required for the removal of rainwaters. Kumpara sa if mailawom ang railroad, dili ta manginahanglan ana. So, for the last topic of our group is the bicycle lane. So, bicycle lane is now becoming popular due to necessary. So, bicycle lane is now becoming popular due to energy crisis and traffic problems. It requires a separate road for the riders that are entirely separate from the vehicular traffic. For example, na sa ubos magkita maginato. Og bisag kita gud sa Cebu City makakita ang mga bike lanes. However, naatay bike lanes pero murag di ra magamit kay gihimo mang parking lot og naay mga motor dito pod moagi. So naatay law nga bike lanes pero ang mga tao may mo problema kay di mo sunod sa law. So the design lane is the design speed is 20 to 30 kilometers per hour. For flat section. The width is 2 meters minimum for a two-way travel at a grade of the lane is 5% maximum on short distances. So the minimum requirements for a two-way bicycle lanes is 2 meters. So tag 1 meter kada tao. So 1 meter padong dito o 1 meter padong dire makita nato dire sa image nga naa sa kilid. And that is where our topic ends. Hope you understand our topic from the first from the first topic discussed by Jacob Rel de la Casaho and up to this final topic. Thank you for listening, and this is all.